So now we're going to get into the first session. The first session is looking at AI ML and opportunities to look at energy efficiency, to look at the workload optimization. And Bharath is going to host that panel. Bharath, I'm very happy to say Bharath's on my team. He's one of the senior technical leads at Meta. And his area of focus is AI ML. He works on the infrastructure team. So he's very involved in the day-to-day and the long-term future technology directions. And he has assembled a fantastic group of speakers today, and there'll be a panel discussion at the end. I'll pass it over to Bharath.
Thank you, Catherine. I'll go ahead and share my screen. Good morning, everyone. I'm really excited to be here today. I think John opened up with a powerful statement around 100 to 1000x efficiency improvement in order to support carbon neutral AI. That is a very powerful statement to rally around. And hopefully through the sessions this morning, we will discuss why that's important and almost existential to drive towards in order for us all to have a more sustainable AI-related power footprint. For today's session, I'll start off by kicking off some of the use case deployments and giving the next level details of why this 100 to 1000x is going to be important. So that we'll do for the first part of it. And then I'll introduce the panelists today, which are a good representation across technology providers, end users, and academic collaborators, and the range of topics across the code design spectrum that they'll be covering today. And then finally, we'll wrap up this session in the afternoon around 11:30 with a panel where we will discuss what are the opportunities and areas of prioritization and focus for IEE going forward in the space of AI ML. So that is what we will cover through the course of this morning session. And I look forward to discussing this with you all today. I also want to make a call out for my colleague, Divatsa Mudigari, who's on the call today. He's largely my partner in crime on these efforts and partnerships with UCSB. And he will also be joining us for the panel session later today. In the case of the use cases, the challenges with AI is not just that it's important. There are a variety of use cases that kind of range all the way from the data center to endpoints, and they continue to proliferate at a rapid pace, right? We largely depend on things like, we have moved away from, not moved away, we have started with content understanding, recommendation models are very important for us, natural language processing, video-based AI, and now as we head into a new focus areas around metaverse, the key types of AI applications are continuing to segment, and that drives the need for optimizations at different levels. And that, I think, is one of the interesting areas of how we can look at this going forward, not just at the data center level, also going all the way through the edge. So we'll look into the next level of details on what may be some of the opportunities that we can look at in terms of how we optimize this going forward as a community. The first vector that I think Catherine somewhat alluded to is primarily around the hardware complexity. It is a little bit more manageable if all the complexity goes in one direction. But as these workloads around AI segment, there are different levels of optimization. A content understanding model is very different than a recommendation model. So if you look at this picture that's being shown here, DLRM, which is one of the focus areas for recommendation models, they are not that intensive. If you look at the left chart from a compute standpoint, if you look at the petaflops and things like that, they are not that high in terms of an order of magnitude relative to something like a GPT-3 kind of a use case. But then when you look at it on the right side, they are very different and more demanding in terms of the number of parameters and then the need to communicate the results of these computations between across the networks, whether it is all-to-all or all-reduce and things like that. And what this means from a data center use case is that as these workloads grow in scale and they also segment, we need optimization points because they become large enough, to the earlier question, for these different types of use cases at some level in order to drive towards those high energy efficiencies that we are talking about. So this is clearly a workload-based model through which we can apply efficiency is a key angle. So from a meta perspective, we have made many of these workloads available to the community, such as the DLRM-based models. And we continue to make available more and more models, whether it is training or inference. And so this is clearly an area that a vector for focus. And we talked about this a little bit in this segment earlier around the fact that DLRM is different than the transformer. And I think I just covered this in the earlier slide as well. So I'll just move past this. So now getting into the scale of it, right? Even though we talk about AI in the context of training and inference, they're really different problem statements and they drive different types of optimizations. So for instance, on the training side, there are lots of investigations happening around how we deploy liquid cooling, how do we have dedicated infrastructure in order to drive more optimized cooling for training-based use cases. But the same types of optimizations don't naturally translate into the inference space in cases. So where for inference, we really focus around performance per watt as well as having an air-cooled infrastructure. But if you look at this graph, right, they both continue to grow at a pretty rapid pace. Like Catherine mentioned, this slide is also, I would say, a year plus old. So when you look at an aggregate growth of like 4x or something along those lines on training and inference, this CAGR, I would say at this point in time, just has continued to accelerate even further. So it's currently not showing any signs of tapering out. So you see both inference and training, they do require different types of optimizations, and that also presents an opportunity for what are the types of areas of research and focus that we look at going forward. The other angle I wanted to point out is that when these things become at scale from a data center perspective, the reliability of these machines becomes of paramount importance. These workloads are now doing more mission critical computations. So things like silent data corruption errors, things like error handling, how reliable are these systems, that becomes a very key metric for us because many of these workloads run for a long period of time, and the computations that they end up doing, they end up getting used into things like serving ads and other kinds of use cases. So the reliability of these systems in terms of silent data errors and those kinds of things at the scale of deployment that we're talking about is a key angle for us also looking going forward. AI is also starting to touch, going back to an earlier question, we clearly can say here what percentage of AI is a part of our overall compute infrastructure. But we can say that AI is large enough that it drives independent decisions in terms of how we design and deploy in the data center. So for instance, AI requires a separate backend fabric. AI is big enough and we are willing to invest in it to optimize. So maybe my guidance to this discussion would be that AI is big enough that it drives independent optimization decisions, and that can be an assumption we can all use as we look forward in terms of the opportunities here. A part of the Moore's law slowdown curve that Catherine talked about is that we probably will hear more from the technology providers. We have presentations from NVIDIA and AMD going forward, is that we see a trend where the accelerators continue to grow and into higher power envelopes. What was 300, 400 watts is now getting closer to up to a kilowatt in terms of the types of power profiles that the AI accelerators are driving towards. And what this requires is a different type of cooling solutions relative to our traditional compute solutions that we deploy at scale. So this has driven investigations and investments in areas like air-assisted liquid cooling within a rack. How do we design our next generation data centers with more capabilities to supply this AI infrastructure? And so clearly AI data center design is also another area which is ripe for investigations as the AI scale continues to proliferate. So in terms of, this is, I think, a good segue to the mission statement that was laid out, 100 to 1000x efficiency improvements to enable a carbon neutral AI. So the picture that is being shown here, the red line basically explains why the current trajectory is just unsustainable, right? So if you look on the left, you see the growth in the model complexities that Catherine alluded to, which is the green line, which is on a pretty exponential curve that was described earlier. So today, some of our clusters are in the hundreds of kilowatts, right? Which is the, are already in the hundreds of kilowatts, which is what the bottom dot in the red chart is plotting. And if we continue to go with the types of model complexities that we are talking about, you can see an extrapolation of what that would mean in terms of a power footprint. Clearly, building this class of data centers and this number of data centers is just not practical. So there clearly is a need for energy efficiency in this space. And so I think some of the questions that were coming in the earlier part, I think they were asking around, is this a big enough problem? And without going into specifics, we can clearly say that this is absolutely a big enough problem, and the community needs to come together in order to collaborate and make this path forward much more sustainable. So what is it that we need as we look forward into the space, right? And this gets into the co-design team that I think we will hear towards this, right? But I think in terms of opportunities, we are looking at opportunities pretty much across the board, right? Starting from data center design to compute storage, memory network optimizations, computation memory, hardware design. How do we optimize our hardware design infrastructure, cooling at various levels, whether it is within the rack or at enabling capabilities at a data center level, and all the algorithmic innovations that can come from a software layer. All of these are areas that need to work together in order to flatten the curve. The picture on the left seems like it's pretty much a small delta between the red and the green line, but clearly it's an exponential view in terms of how we are looking at it. And so clearly this is the focus for us as a community going forward. And this is, again, laying out a different view of it. Catherine talked about this a little bit earlier, and the focus is just not in training and inference. The data ingestion pipeline from a storage standpoint is also a key consideration for us. So there are opportunities for this across the flow as we look forward. So this is the piece that gets exciting, right? So the challenge is so broad and so important. This is going to require not just a company or two companies or 5 companies making this happen, right? It is going to require a broad collaboration and effort in order to make this happen. This collaboration needs to happen across end users, technology providers, system providers, academia, data center design, standards body, you name it, right? So this is something that is going to require the effort of the entire industry in order to build this future that is a lot more sustainable for green AI. So there is clearly a lot of work ahead of us, and industry participation is critical, and we look forward to partnering with the industry. So this was the basis through which we conceived the panel today. And so now I want to transition into the panel today in terms of what we are focusing on. So clearly we have distinguished speakers here from NVIDIA, AMD, UCSB, Broadcom that are here today. And if you look at the range of topics that are listed out there, they start to touch upon the different types of problems that we discussed in the earlier slides. Clearly, what are the next level details of the cluster trends and the accelerated computing trends is something that Rob and Frank will cover. Cliff is going to be here to talk about how Google is looking at some of the cloud accelerators and how they are driving energy efficiency in that space. We have a couple of presentations from UCSB around how you look at it from a software code design standpoint around compiler and runtime support. And then Surendra is going to be discussing a highly energy efficient training network fabric. So hopefully the presentations today give you a sense of the opportunities that different participants in the ecosystem are pursuing towards bending the curve, so to speak. And then once they are all done with this, we'll do the roundtable with at 11:30 with all the session panelists and also Divitsa from the Meta team. We will be back at 11:30 to do a panel. In terms of the sessions themselves, we invite questions from you for as the presenters are speaking, and we will make sure that we try and answer at least 1 or 2 questions per speaker as their timing allows. So with that, I think clearly the mission of IEEE in terms of 100 to 1000x energy efficiency for AI is pretty spot on. And I think it's a key necessity from an industry viewpoint. And I look forward to the sessions today. I'll just pause and see if there are any quick questions. If not, I will introduce Rob over from NVIDIA, who will be the next presenter.
While you do that, I might bring up my presentation.